Today, we'll learn about sentiment analysis. This workshop assumes some prior knowledge of Python and machine learning. All materials can be found on our GitHub repository. The link will be provided in the description box. We recommend using Google Colab for this workshop. To set up Google Colab, you can simply Google Colab. To load our demo notebook, click the GitHub tab, and then paste the repository link that we provided in the description box. Click the magnifying glass icon to load the notebook. Today, we'll use this hands-on sentiment analysis with Python. Now we're in the Google Colab environment with our notebook. Google Colab has two types of cells, code cells for Python code and text cells for note and instructions. We can run the code cell by clicking on the play button or using Shift plus Enter. We can edit a text cell by double-click on it, and after that, we can press Shift plus Enter to finish editing. Sentiment analysis identifies subjective information in text, like opinions and emotions. We'll use Yelp restaurant review data to analyze customer sentiment. First, we'll explore and pre-process our Yelp dataset. We'll use Natural Language Toolkit, NLTK, to feature extractions and scikit-learn to train a machine learning model to predict review ratings. We'll also use out-of-the-box techniques like VADER, which consider valence, and RoBERTa Pretrained Model from HuggingFace. Finally, we'll use the HuggingFace Pipeline for sentiment analysis. Now that we're ready, let's begin our sentiment analysis workshop. Before diving into sentiment analysis, let's first import all the necessary libraries and packages we'll need for data manipulation, visualization, and natural language processing. Now that we have our libraries imported, let's load our Yelp dataset, which can be accessed and downloaded from the Yelp Open Dataset. Our dataset has 10,000 entries with 10 columns each. Let's take a look at the first few entries. Now that we've got our data loaded, let's explore the distribution of reviews in terms of stars. As we can see, the majority of the reviews have 4 and 5 stars. This gives us a better understanding of our dataset's distribution. Now that we've explored our dataset, let's classify and split it into reviews and stars. We'll focus on negative, neutral, and positive reviews, which are 1 star, 3 stars, and 5 stars. We'll only use the first 3,000 data points for today's workshop, but you can try to use all of the data on your own if you want to. Now we'll separate the dataset into X and Y for prediction. So X will be the review text of the data, and Y will be the stars of the data. Today, we'll not go into the vectorization or preprocessing. So basically, what we've done with preprocessing is we did the vectorization of the preprocessing data to convert the raw text data into numerical format for machine learning algorithms. Here, we can see the sparse matrix we got from the preprocessing and tokenization. If you want to know more, make sure to check out our text analysis with Python workshop, which will be linked in the description box. Now that we have preprocessed the data and created a sparse matrix, we can use machine learning algorithm to build a sentiment classifier. We'll try different algorithms and compare their performance. First, we'll import the functions to zip the data into training and testing sets. And we're also going to import different functions from scikit-learn for classification report to evaluate our model. We'll also use GridSearch CV class from scikit-learn for hyperparameter tuning. After importing the data, we'll split the dataset into training and testing set. We use test size of 0.2 so that 0.2 of the entire dataset will be considered as testing set. We'll now use multiple machine learning algorithms to see which gives the best performance. We're going to see multinomial naive Bayes model, decision trees, random forest classifier, support vector machine, and k-nearest neighbor classifier today. First, let's start with multinomial naive Bayes, which is a popular choice for text classification problems. Now we can create an instance of the multinomial naive Bayes class, MB equals to multi-MB. Then we can train the multinomial naive Bayes classifier with our training set, and we'll use this by the fit function. Then we can use the train classifier to predict the sentiment of the test set. We'll name it predict maybe the predict. With that, we can compute our accuracy score of the multinomial naive Bayes classifier. We'll run the score to 2 decimal places. After that, we can just print the confusion matrix and also print out the accuracy score and the classification report. You might be wondering, what does confusion matrix stand for and what is classification report? How do we understand it? So a confusion matrix is a table that shows the number of true positive, true negative, and false negative. Just as shown here, we have the predicted value in the columns, and in the row we have the actual values here. By plotting them together here, we can understand what values are correctly being predicted, what values are wrong. So here we can see that there will be each classes of the true value, predicted value here in the columns, and then in the row are the predicted values. And the higher the diagonal numbers are, the better the model is. And the score listed in the output is the overall accuracy of the model, which is the percentage of the correct predictions across all the classes. In the classification report, we have precision, recall, F1 score, and support. Precision will measure the proportion of correct prediction among all the positive predictions for a particular class. Recall will measure the correct predictions among actual positive instances of a particular class. F1 score is the harmonic mean of precision and recall, which provides a balanced measure of the model's performance. In the output provided, the classification report shows the precision, recall, and F1 score for each class 1, 3, and 5, as well as the overall accuracy. The macro average and the weighted average, just a weighted average of precision, recall, and F1 score for all the classes. Now that we know how to understand the classification report and evaluate different models, we can move on to our next models, which is the decision tree. It's a simple model that uses a tree-like structure to make decisions based on a set of input features. Similarly to before, we'll also import the decision tree classifier from scikit-learn. And we can also build an instance, fit our training data, and get our predict result and calculate the score. Here is the confusion matrix, and we have a score of around 65%. The next model is random forest classifier. It's a popular ensemble method that combines multiple decision trees to improve performance and reduce overfitting. You will incorporate a set of decision trees on different subsets of the training data and use random feature subsets. Similar to before, we'll import random forest classifier and also generate an instance, fit our training data, get a predict result, and calculate the score. You can see that we have a score around 69%, which is slightly better than decision trees. The fourth model I want to introduce is Support Vector Machine, SVM. It's a powerful model that works by finding the hyperplane that maximally separates the training data into different classes. Using SVM, we can get a score around 71%, which is slightly better. The last model I want to introduce is the k-nearest neighbor classifier. It's a simple non-parametric model that works by finding the k-nearest neighbor of a new data point in the training set and assigning the most common class label among its neighbors as the predicted label. The implementation is similar to before. We'll use pre-built k-nearest neighbor classifier. The score is around 61%. From the above algorithm modeling, we can list the accuracy for each model. We can tell that the highest accuracy we can get is from the multinomial naive Bayes, which is around 77%. So you can choose different model depends on the specific task at hand and the size and complexity of the data. Usually it's a trade-off between accuracy and computational efficiency. Since multinomial naive Bayes has the best score, we'll just use it to predict a random positive review, a random average review, and a random negative review. So now we will pick a data from the dataset. We know the first data is a positive one, so we just use it as an example. And we can print out a positive review. Here, it talks about what's the occasion, and they cannot wait to go back. So it's very positive. And we can print out the actual ratings. Which is a 5-star. And now let's try to use our classifier to predict the data. Similar to before, we cannot just use our classifier on the text directly. We have to transform the text into a matrix or a vector. We can also print out the transformed matrix just to take a look. You can see it's all numerical. Now we can run our prediction, and let's print it out and see. The predict rating is also 5. And we can do the similar thing for the average review. And also negative review. You can see that the actual rating was 1, our predict rating is also 1. Another thing I want to mention is the bias in the dataset. Remember, we had a bar chart about the distribution of the data, and we knew that there are a lot of reviews that's 4 stars and 5 stars. It's probable that the dataset contains a higher proportion of positive reviews in comparison to the negative ones. To address this issue, sometimes we can use normalization of the dataset to equalize the number of reviews so that the potential solution can be less biased. So now we know how to use scikit-learn packages to build a sentiment classifier with different machine learning approaches, including multinomial naive Bayes decision tree, random forest classifier, support vector machine, k-nearest neighbor classifier. There's a lot more different models and algorithms. There's also a link in the description box that will take you through different types of models and what are the disadvantages and advantages of different types, so you can choose the best model for your own project. So now let's explore some out-of-the-box techniques for sentiment analysis. We'll look at 3 different ones. First is the VADER, back-of-word approach, and then we'll look at RoBERTa Pretrained Model from HuggingFace. Finally, we'll introduce some HuggingFace Pipeline that can help you build your project real fast. VADER is a lexicon and rule-based approach that utilizes a pre-trained dictionary for words to determine the sentiment of the text. This approach is useful when we don't have labeled data or we want to quickly analyze the sentiment of the large volume of text. We'll use NLTK sentiment intensity analyzer to get negative, neutral, and positive scores of the text. So this essentially uses a bag-of-words approach. So the stop words are already removed, each word is scored and combined to a total score. We'll start with downloading some of the VADER lexicon package from NLTK corpus, which will provide the sentiment lexicon for the sentiment analysis. We just need to simply do NLTK.download. So now we'll just import the sentiment intensity analyzer from NLTK. We'll also import the TQDM so we can see the progress. So first we can initialize our sentiment analyzer. We can just do it by simply calling the sentiment intensity analyzer. Now we can just try to use it with some phrases directly. Here we just call SIA.popularity score. Something like very positive, I am so happy. You can see the negative point is 0. We get some neutral, and positive it's around 0.68. So it's pretty high. Compound score tells you basically a combination of the previous 3. The higher the score is means it's positive. Now we can also try it on some phrases that's negative. Weather is not that good. And you can see that our analyzer thinks the weather today is not that good. It's kind of a neutral phase, but slightly on the negative side. Now we can use this analyzer on our previous example, just to give us a reminder of how the example looked like. We'll print it out. Yeah, it says, this place is definitely good for what it is. And the cherry on top for like Japanese beer. So it's pretty positive. And we can use our sentiment analysis on this example. So we can see here, there's the score for negative, the score for neutral, and the score for positive. And overall, our analyzer thinks this is pretty positive, which is true. Now we can use our data on each one of the reviews, but it will take some time for the analyzer to run for all the reviews, so we'll just use the first 300. Feel free to run for all the data points on your own. Now we can write the function to compute the sentiment score for the entire dataset. We'll first create an empty dictionary, RES, as a result, to store the analysis result for each business ID. Now we can just iterate over each row of the data frame, and then also display the progress bar with TQDM. So analysis is done for the 300 data points. We can take a look at the result. We can see that for each of the business ID, we have 4 different points, which is a negative, neutral, and positive compound for the text reviews. But now we want to combine them with the original dataset, and we'll just connect it with the column of index as business ID. Now we can print out the sentiment score and the original metadata together. Here is the business ID. We have a negative, neutral, and positive compound combined into this dataset now. So right now for our VADERs, we have 13 columns instead of 10 because we're adding these results into the original dataset. We can also plot the VADER result. We will just import Seaborn to plot a bar plot in terms of stars versus the compound points we get. And we can see here, for lower stars, we get a compound point that's slightly lower. For the higher star, we get a scores of the compound score that's also higher, which is what we expected. But we can see here, when the stars is lower, the compound score has a very high ranges for 1 and 2 stars, which means that the analyzer is not sure about how negative these reviews are, but for the positive reviews, our analyzer is pretty confident about it. We can also generate different graphs, so we can look at the positive, neutral, and negative separately instead of looking at the compound. So for the positive ones, we get a higher score for higher stars, and not much difference for the neutral, which is expected, and for the negative, we get a higher negative points for lower stars, so that we can see our VADER model works pretty well. Next, let's look at the RoBERTa Pretrained Model. The RoBERTa Pretrained Model from HuggingFace is a deep learning-based approach that utilizes a pre-trained language model to extract features and predict sentiment. This approach is useful when we have a large volume of data and want to leverage pre-trained model to avoid the need of extensive feature engineering. So let's start by installing the necessary libraries and loading the pre-trained RoBERTa model. We're installing the transformer packages. If you know about GPT, you will know the T stands for transformer. So from the transformers, we can import tokenizers, the sequence classification. We're also going to use softmax function from the SciPy library, which is used to calculate the probabilities. We are using the model that was built on the Twitter data, and we just initialize the tokenizer from the pre-trained model. The RoBERTa transformer model is better than VADER model because the VADER model is using backup words, which is considered each single word individually. But transformers can consider the context and the sentences together. Now let's define the function to apply the RoBERTa model to our Yelp reviews and calculate the sentiment scores. So we'll tokenize the input text using the pre-trained tokenizer object. The return tensor arguments specify that the tokenized text will be returned in a PyTorch tensor format. And we can store our output. What we did here is we unpack the tensor named argument into the model with this 2-star syntax. And then that we want to extract the predicted class score from the model output tensor, converting it to a NumPy array. And then we can just apply the softmax function to convert the class scores into probability and sum it to 1. And then we can create a dictionary that maps the class name to their corresponding probabilities. And we'll use the same keys as the RoBERTa negative for the negative class, neutral for the neutral class, and RoBERTa positive for the positive class, so that we can differentiate the scores. Now we can print out. Here we get a dictionary similar to the format in VADER. So for the RoBERTa, we get the negative score, the neutral score, and the positive score. And we know from the previous example that what we have is pretty positive, so our positive score is the highest. Now we're doing it by passing in whatever text we want to analyze, and you will return a dictionary as before. So now we can use this function directly, and we can analyze each one of the reviews. Now we'll iterate each row. We want to extract the text and business ID from the current row. And then we'll apply VADER sentiment analyzer to the text and store the result. This is what we did for the VADER text. The different things is that we want to name all the result with VADER dash, so we know it's the result from VADER model. Now we can apply the pre-trained RoBERTa model to the text and store the result. This is just the function we defined earlier here. We're just using it directly. Now we can just combine VADER and RoBERTa sentiment scores dictionary into a single dictionary by calling both. And then we can add the result dictionary to the res dictionary as a result and use the business ID as the key. If a runtime error occurs, we'll print a warning message to indicate the problematic business ID. Because I've run the model before, I know some text in the review is too long, so the RoBERTa model will have some problems. RoBERTa model usually takes some time to run. So now we have finished running the RoBERTa model, and we're combining it together with the VADER model result and also into the original data frame. So now we can compare the scores between the two models. We can first take a look at the columns of the data frame. So we have the business ID, and for the VADER, we have negative, neutral, positive, and compound. For the RoBERTa, we have negative, neutral, positive, and the rest date review ID are the original data frame data. Now we can build a pair plot. Pair plot is a matrix of scatter plots and histograms where each variable in the data frame is plotted against every other variable. The purpose of the plot is to visualize the relationship between different sentiment scores generated by VADER and RoBERTa model. Same with the bar plot, we're using SNS, Seaborn, and we're calculating the relationship of the VADER negative, neutral, positive with RoBERTa negative, neutral, and positive. The hue will be by the star. It is a little bit intimidating if you're looking at it for the first time, but what we're trying to see here is just the diagonal part here. For the y-axis, we have the VADER negative, neutral, positive, and then RoBERTa negative, neutral, and positive. And here is also plotted the same in the x-axis, negative, neutral, positive for VADER, negative, neutral, positive for RoBERTa. Different colors means different stars, 1, 2, 3, 4, 5 stars. Let's first look at the VADER. We can see that for the reviews, for the negative reviews, all the stars are more towards the left side, which makes sense. And then for the neutral, it's towards the middle. And for positive, it's like this, and we can see some pie apart. But all the stars are not very well separated. However, for the VADER model, we can see that for negative parts, neutral parts, and also positive parts, we can see a gap, really a gap between different stars. So in the pair plot, the diagonal part of the plot shows the distribution of the single variable. If the distribution of the sentiment score is centered around a particular value, this may indicate the model is not performing very well. So that's what we see in the VADER model here. They're not very clearly separated. On the other hand, if the distribution of the sentiment score is spread out and not centered around a particular value, this may indicate that the model is performing well and capturing a range of sentiment expressions. This is kind of what we see here in the RoBERTa model. So we can see that comparing VADER and RoBERTa, the distribution of the RoBERTa is a lot more spread out, so it performs better, which makes sense because in terms of natural language processing, we always want to consider the context and the relationship between words instead of just analyzing the word individually. Now, let's take a look at some review examples. We'll take a look at the positive sentiment of 1-star review and the negative sentiment of 5-star reviews. So now this is a positive sentiment, but it's only a 1-star review. Let's see what's confusing part about this text. Really, I can't believe this place has such a high review. So I copied the entire text here so we can know the polarity score of it. We can see that it's not considered very negative, but it's very neutral. And in terms of compound, the sentiment analyzer give it a very positive one. And we can know the text is super long. That might be part of the reason why the model think this is a positive sentiment. So I copied the same text to see what kind of score RoBERTa will give. For the negative part, we can see that RoBERTa gives a pretty high score for the text as negative and neutral and positive. So in terms of this one particular text, RoBERTa did better than the VADER model. So we can also do the similar thing for the negative sentiment, but that got a 5-star review. So we'll start with VADER model. I love this place. The pizza is cheap and good. It is very positive if we read it because it says, oh, the pizza is cheap. But maybe RoBERTa is considered some of the words is negative, like doesn't, cheap. That might be the reason. But let's take a look at the score. Yeah, we can see here VADER does think this is a negative. What about RoBERTa? Let's take a look. Being Indian, having grown up in London, I've been pretty spoiled in Indian food. We can see here this sentiment does sound a little bit negative because he's not very happy about the restaurant itself, but it's okay in terms of something that's close to home. So maybe RoBERTa is right. Finally, I want to introduce the HuggingFace Pipeline. This is a high-level API that allows us to easily utilize pre-trained model for various natural language processing tasks, including sentiment analysis. This approach is useful when we want to quickly and easily analyze the sentiment of text data without the need of extensive coding or model training. All you need is to import the pipeline from the transformer, and you can just initialize the sentiment pipeline. And really, that's it. You can directly use sentiment pipeline with any text you want to analyze. We can try to write something positive here. Okay. And use labeled positive with very high score. We can also try to write something really negative. And it's considered negative. So remember, out-of-the-box technique might not be ideal for every task. For a specialized dataset, a custom model will be more effective than pre-trained or lexicon-based approaches, even though it was super convenient. The best approach depends on the task data and the available resources for training and implementation. This is the end of our workshop. Feel free to check out our GT Library Data Visualization GitHub. In there, you can find the complete notebook and also other repository for other interesting topics and projects.